Okay, it's 12 now, so hello everyone. Welcome to our webinar about visual scripting with Bolt. My name is Marek, I'm an evangelist at Unity, and I'll be hosting the webinar today. As you probably already know, earlier this year, Unity has acquired a visual scripting solution named Bolt, and we've made it free for all Unity plans at no extra cost. And this is free for no matter if you're a Pro, Plus, or a personal user. This is very exciting because in the past, Unity relied solely on C# scripting. If you wanted any sort of visual solution, you would have to go to the asset store and buy a solution like a Bolt or maybe a Playmaker. And programming itself, this is of course not a preferred way of creating gameplay interactions or any scripting if you're not proficient with programming, right? If you've never written any C# code, this might be a little bit challenging. C# itself, I think it's a very, very friendly language for beginners. So if you'd like to try writing C# code, I really encourage you to do so because it's not as difficult as it might seem. But for beginners, I think having a visual scripting solution is something really great. So before we start, let me briefly tell you about the structure of this webinar. So once again, welcome to everyone joining on Zoom. I hope that you can hear me and see me clearly. Welcome to everyone joining on YouTube. Unfortunately, I won't be answering questions posted on the YouTube live chat today. Only the Zoom users will be allowed to post questions in the Q&A window. So if you are tuning in on Zoom, please ask your questions whenever you want. I'm going to stop several times during this webinar to try to answer them all. And if you want to join the post-webinar discussion, I've set up a channel on our local Discord. So we have Unity-ANZSEA Discord, and I set up the channel there. So if you if you use this link, this is an invitation to a channel dedicated to this webinar. So if there are some things that were not very clear during the webinar, we can bring that discussion there. In the past few months, our original Discord actually grew quite significantly, and I hope that we can have a great post-webinar discussion there. A few people are asking if there is going to be a recording of today's session, and yes, we're going to post the entire thing on our local YouTube channel. So again, we also have the Unity 3D ANZ So this is our original YouTube channel, and the entire thing is going to be posted there. Feel free to watch some of our previous webinars. We already got some about AR Foundation, AI Planner, ML Agents, Physics Dots, and a few more. I would also really appreciate if you can take 5 minutes to fill in the post-webinar survey. It would be very beneficial for me and to my team to know if you like today's content, and it will also help us choose the next topic and better understand what are your needs. Unity is now used not only by game developers, we also see people from other industries like animation, engineering, construction, and others using our tools. That's why we ask some questions in the survey to better understand where the feedback is coming from and how to give you better webinars. So with that being said, let's take a look at the agenda. I'm going to start with the introduction. So basically today's content is divided into 3 sections. The first 2 are basically me talking to the PowerPoint presentation. This is going to be maybe 10 minutes or so. And the last one is going to be about giving you some real life examples. So in the first one, we're going to start with a quick introduction to scripting. And in this section, I'm going to give you an overview on how to create gameplay interactions with visual scripting and how does it differ from traditional programming using a C# language. Then we are going to move on to the installation setup to get you up and running. This is going to be very quick. If you are watching this after the live webinar on YouTube, I'm going to add some timestamps so you can skip this part and navigate directly to the examples. And finally, I'm going to give you 3 demos. The first one is going to be a very simple project. It's actually kind of a remake of one of the early tutorials that we created at Unity. It's called Rollerball. So we have this simple sphere with rigid body and a sphere collider, and we're going to use our keyboard to move it around. And it's very, very simple and great for demonstration purposes. Then we are going to see how to create simple scenario with a third-person character. So I took this scene from a 3D game kit Lite. This is something you can get from Unity Hub. If you go to the Learn tab, there is a 3D game kit Lite project, and it's extremely simple. So we have this button, and when you stand on a button with your third-person character, these doors are going to open. So that's the entire interaction. Yes. Oh. Okay, sorry about that. Can you see it now? Okay, so sorry about this. I forgot to click the share button. So this is the Rollerball project that I mentioned just now. This is the trigger interactions, and finally we are going to last but not least, we are going to create an AI state machine and use it to create an interesting behavior. So you can see here we have this enemy that's traversing the scene. He's going between patrol points, and once he see a player, he's going to start and chase us, and if he's in an attack range, he's going to attack. Okay, so let's start with a brief introduction to scripting in Unity to give you some motivation for trying out Bolt. So Unity's primary way of scripting is using a C# programming, and most of the scripts, they are inheriting from mono behavior. So if you write a script in C#, this is a template script. The default one is going to inherit, so this column here means that we are inheriting from the mono behavior. And this means that the parent class is a mono behavior, and it makes it possible to make this script a component. So basically, if something is mono behavior, you should be able to add it as a component to your game object. All of these scripts, they have the .cs extension. They can be edited in virtually any text editor. The default option is Visual Studio or JetBrains Rider. But this is basically how it looks like. And the component pattern that I mentioned just now, this is the main pattern that's used in Unity, and it's a great way of splitting your game logic into behavior as logical bits. So, for example, we have a transform component here, and we have position, rotation, scale. Then we have the animator that's responsible for displaying animation, character controller, and also we can add our custom scripts here as components as well. So these custom scripts, like for example this damageable script here, they are the main way that we can use to create gameplay behaviors. And when we create C# scripts or any sort of scripting, this is going to apply to visual scripting as well. We are utilizing some of the special callbacks, some special methods inside Unity. And the main ones are the ones that I listed here. So when we start our scene, first every single script is going to call the awake method. So this is like a callback that's going to be called every time you load a scene, before anything else starts, you can be sure that everything in an awake is being executed. Then we go on to start. So start is a method that's going to be executed before the first frame appeared on the screen. Then if your game or experience is running 30 frames per second or 60 frames per second, then this method update is going to be also called 60 times a second. So if you maybe read keyboard input or create some interactions, update is the method, it's the function that you're going to use very often. Then you have things like fixed update. Fixed update is very similar to update, but it's not tied to rendering. It's not tied to frames per second. It's tied to your physics update. Then we have things like late update. I'm not going to mention this today. On destroy is called when you basically when your object is destroyed. On collision enter, on collision stay, on collision exit. These are great methods if you want to create some interactions when two objects collide with each other. And today I'm going to actually implement one behavior using the on trigger enter. So when our player enters certain trigger area, we are going to be able to trigger certain gameplay events in our scene. So the coding with C# or programming languages, it's not really a preferred tool for everyone. From my experience, I know that many designers and artists, they prefer to use visual tools because they give them quick feedback and they're much less error prone. If you write C# code, if you forget one semicolon, the entire script doesn't work. So it's way easier to start with visual scripting solutions. And actually in Unity, we already have several visual graphs to make creation process more intuitive and artist friendly. So here we can see the animator that's using the states for the animation, the shader graph, the VFX graph. They are all visual scripting solutions in a way. So let's take a look how Bolt compares to our C# and how does it make it easier for us. So here you can see a very simple method. This is the start that I just mentioned just now. So void, it basically means that there is no return value. Then on the start, so basically before the first frame of our game is displayed on the screen, we are going to call this method. And here we are going to get reference to every single object that has a player tag on it. And then we are going to use this for loop. So for loop is something that allows us to iterate over a collection of items. And we are going to iterate over all these players and display the name in this pattern. So player number is named player name. So you can see here how it translates to the visual scripting. It's I think it's very, very clear here what it does. We have a start event. Here we can provide the control flow. So on start, we just need to drag and connect it with the next thing we want to do. Okay, so on start, we're going to call this one find game objects with tag. We're going to provide the tag that we want. So this was this player here. Then we are going to set an object variable. In visual scripting, we also have the concept of variables. We're going to set the player's variable and iterate over every single player. And then let's take a look at the control flow. After we come here in the for loop, on every iteration, so if you have 5 players, this is going to be 0, 1, 2, 3, 4. On each one, we're going to create a new string here. The string is basically a string of text, so we're going to create a new text here, player number, then we're going to give it index, so this will be 0, 1, 2, 3, 4, is named, and then we're going to pass a name here from this get item. And debug log, this is something that we use very often to print things to our console. So when using Bolt, you have a choice to use either Flowgraph, so this is the one on the left here, or the state graph. And flow graphs, they are much more common. They let you create actions every frame, or when certain events happen, like on start or maybe trigger or collision occurs, then you can provide some behavior here. And also they're great for performing things like branching, loops, maths operation, and things like that. You're probably going to find yourself using flow graphs more often than state graphs. And the state graphs, on the other hand, they are used when you want to implement some high-level logic. So this could be something like a game state. So maybe you have game is playing, game lost, game won, things similar to that. It could be character state, like maybe your character is alive or is dead. Or it could be a state machine. So we're going to use an AI state machine as the last example today. Okay, so this will conclude the introduction part, and I'm going to move over to the installation and setup. So it's relatively easy. As I mentioned before, Unity provides Bolt available for free from the asset store, and I'll quickly walk you through some steps how to get it up and running. So if you are using Unity 2019.4 or lower, this will be available through the Asset Store tab, and for 2020.1 or higher, you'll have to do this through the Package Manager. So let me show you quickly how you can get it for the 2019.4 or lower. So first you need to go to the Asset Store tab, okay, and you need to search for Bolt. There are several assets that have similar name, but you want to look for the Unity Technologies Bolt. You want to click on that and download and import this into your scene. It will create this pop-up window here, and then you just need to click import. So that's basically it. It's super simple. For Unity 2020.1 or higher, the asset store was actually removed from the editor, and if you want to get your asset, you first need to go to the website. You need to log into your account, you need to look for Bolt, click add to my assets. Okay, it will give you this window here, add it to my assets. Then if you go back to Unity, you should be able to open the package manager, and from the package manager you want to switch to my assets, and you should be able to see Bolt in the list here. So it's exactly the same. You're going to click import, it's going to import the entire thing into your project. Now, after successful import, you should be able to see this new tools menu. So we want to click install Bolt and then click import. So Bolt supports C#3 and C#4.x. It's going to automatically detect which C# version your project is using. For the new project, the default is going to be for 4.x. So click import. This might take a minute or two, and you're going to see this wizard. So here you can choose human naming convention or the programming naming convention. I chose the human one. It's right here, the human naming or the programmer naming. If you're new to Unity, I suggest the one on the left, because it's going to give you more readable, friendly way of naming things. Then we have the assembly options. So if you are not using any like custom DLLs, you just need to click next. For the type options, basically all the mono behaviors types I included, so you can just go ahead and click generate, and this is going to generate all the Bolt files for you. This step, it might take up to a minute. After this is done, you should be able to create your first visual script. Okay, but enough theory. let's go and take a look at some practical examples of how we can create our own visual scripts and how can we create gameplay in our project. So as I mentioned before, we're going to cover 3 simple scenarios that will illustrate how to implement simple gameplay features using flow graphs and state machines. So let's start with this, what I call the rollerball. So here you can see that this sphere is our main character, and our aim is to control it using physics. So imagine that this is my sphere. Okay, it has a rigid body component, so this is a physics component, and I will have to apply some forces to move it forward or backwards, and also left and right. So this is going to be handled using my keyboard. Also, when I press space key on my keyboard, I want it to jump up into the air. Okay, so let me switch to my Unity editor. Going to press play. This is a very simple scene. I just used the Pro Builder. Pro Builder is another really great asset that you can get for free. And you can see that I just put some stairs here, a platform. Very, very simple. I just aim to create a few obstacles in my scene so that when I move my ball around, it's a little bit more interesting. Okay, so this is my main character, and you can see that the only components I have here are transform, sphere, mesh. Let me see what's happening in the Q&A. Okay, you can't see my screen. Just 1 second. Can you let me know if you can see my screen now? You should be able to see my Unity editor. Yeah, all good. Thank you very much. All right, so here is my simple scene. I have several objects here that serve as obstacles to my main character, this simple ball. And you can see I have transform, mesh renderer, so this is responsible for displaying the sphere on the scene. Then I have a sphere collider, this is the collision component, and a rigid body that makes it move down. And that's basically it. Alright, so now if I want to add my new behavior using the flow graph, using Bolt, if I successfully install Bolt, I should be able to right click somewhere in my assets and go to create Bolt, and you should be able to see state macro or flow macro. So now I'm going to select the second one, flow macro, and I'm going to name it something like example 1. All right, and now this is an asset in my assets. All right, and if I want to edit it, I would have to create. I'll have to open a window to edit it. So I can go to Window and go to Graph. Okay, and this is I usually like to dock it somewhere here at the bottom of my screen. I already opened one, so I'm going to just leave it here and drag it a little bit up so I have more space to edit my graph. Now I'm going to select the ball, and how can I associate this graph with my ball? So the first thing I need to do is to add a component that's going to be flow machine. All right, so just come here down to the add component, press add component, and look for the flow machine. Okay, now the flow machine, when you add it, is going to automatically add a new component named variables. So this one is going to hold all different variables that we use in the graph. And the flow machine, the main settings that we can set is the source. So the thing that I created just now, this example 1, it's a macro. So I can just drag and drop and associate it with my visual script, with this flow machine. But what I could also do, I could use the embed. So instead of relying on the asset in your assets, this could be embedded in your component. So This is great if you do something that's going to be used only once in your game, but something that's going to be reused throughout scenes or different scenarios. It's better to keep it as a macro, as I did just now. So right click, create bold flow macro, and this asset, this is something that you can reuse over and over. So with that thing fixed here, I can give it a name. So I'm going to name it something like rollable, and summary, main character script. All right. Now, how can I tell it to move left and right? So, as I mentioned before, I want to use physics, so I need to add some forces to my rigid body, and to do that, I'm going to look for a method, a callback called fixed update. So the fixed update is something that's going to be called every time we update physics. So I'm going to maximize this window. I'm going to double click here inside the Flowgraph. So it's going to bring it to kind of a full screen mode. And now I'm going to right click anywhere in the empty space. This is going to bring this thing called the fuzzy finder. And in the fuzzy finder, you can look for different type of components, different type of collections. So here I'm going to start with the ball. This is the name of my game object. Go to rigid body and add force. Okay, so I'm going to select this one, add force, and in parentheses you can see what kind of parameters does it take. I'm looking for the one that's giving it force and the most parameters. So this is the second one. All right, and now on fixed update we have to execute this node to add the force to move it left, right, forward, backwards. To do that, I need to open the fuzzy finder again. So right click and look for fixed update. Press enter. So now to make it execute, I need to connect these two nodes. All right, so if I connect it like that and maybe add something just to debug and see if it works, I'm going to select the force to be 1, 0, 0. So now if I come back here and press play, what I should be able to see is that it should move in the X direction because we are adding force in the X axis. So you can see that the ball is always rolling to the right. So this is good, but not really what we want. What we want is we want to listen to the keyboard events and move it according to our keyboard input. So a really great way to do that is to look for a get access method. Okay, so there's this input get access name, and this is going to give me interface to get the horizontal and vertical axis. So for my movement left and right, I'm going to use the horizontal axis. So I'm going to give horizontal name here and the axis name, and I'll need a second one, so I'm just copy and paste it using Ctrl+C, Ctrl+V, and I'm using vertical for movement forward and backwards. So now somehow I need to put it inside here. I need to feed it into this force field at my add force, and to do that I can't really use my float value because this axis is going to be giving me just one number. Somehow I need to create this vector 3 that's going to have these 3 numbers. So I'm going to right click, I'm going to add unit and search for vector 3 create, and I will need the one with the X, Y, and Z inputs. Okay, so with that I'm going to drag the output once the vector is created to the force. Okay, and you can see that it started already to give this 0, 0 value here. I'm not sure if you can see it clearly on your side, but there's this new icon that appeared with 0, 0, 0. So now I'll have to get the horizontal, pass it to the X, and the vertical pass it to the Z to move it in every direction. And now if I press any of my keys, I'm using AWSD now on my keyboard, I can move it left and right, backward, forwards. Now the problem I have here is that it's moving rather slow. So to fix that, I will have to multiply this thing by a certain number. So I'll just drag this one here and look for the multiply. Okay, and this multiply, I'm going to multiply it by a variable that I'm going to add into my object. So here, when I maximize my Flowgraph view, I'm going to go to the object, pass in a new variable name here. This is going to be move speed, and the type of this parameter is going to be float. All right, I'm going to give it slightly larger value, something around 10. So now before I pass it here, I need to multiply it with my vector. So to get it, I'm going to right click, get object variable. All right, and here I'm going to look for the move speed. I'm going to pass it here. So now you can see that my ball is much more reactive and it's moving much faster than before. One thing that you also probably noticed is that Flowgraph supports this thing called live update. So I don't need to stop and make it recompile the entire graph. I can just edit my graph live as I play my game, and the changes are going to appear immediately. So this is great. You don't need to stop your game to adjust the graph. Here I have an error because I added my variable when I was in a play mode. So let me add my variable again here, move speed, a float 10. Okay, so this is the basic rollable. What I could also do, I could add another force that's going to push it up every time I press the space button. So let me look for on key down on keyboard input. So here, every time I press the key, this flow is going to be executed, right? So I'm going to need a new vector 3. So I'm just copy and paste that one. I'm going to give it 10 in the y direction, and I'm going to reuse the add force. So I'm going to plug it in here like that, control flow like this, and in the mode I'm going to use the impulse so that there is a bigger thrust, larger thrust when I press space key to move it up in the air. So now every time I press the space button, you can see that the ball is pushed forward. Of course, I don't have any ground checks, so I could do this indefinitely. So if you'd like to make it more like a real gameplay feature, you would have to add some sort of ground check collision to see if we are colliding with the ground, and then you should be able to add force up only when you're on the ground. One thing that you also might have noticed is that I connected the flow only here between the fixed update and my add force. There is no flow here from the get axis to create, right? So what you probably would have expected is that I would connect this one here and plug it to my add force. But with Flowgraph, we actually don't have to do that, because Flowgraph is going to automatically iterate back from this field here, from the force. It's going to move back to multiply, and it's going to see, hey, for the A, I need create, and from create, it's going to look for all the inputs that it needs. It's going to see, hey, I need X and Y. It's going to kind of iterate forward to look for all the inputs are needed for this one here, right? So it's not like you have to always connect them together. Flowgraph is going to be able to automatically kind of roll back and figure out what kind of inputs are needed to execute this method here. But of course, for this add force, we need some execution flow. So in this example, this is going to be our fixed update. So on every physical update, we are going to add the force. This also works with other events like keyboard input. So I saw that we have some questions in the chat. So, do owner of Bolt before Unity acquires Bolt, do we get Bolt 2 for free? So, as far as I'm aware, Bolt 2 is going to be free of charge. Does Bolt work on mobile games? Yes, it will work on iOS, Android, Nintendo Switch should work also fine. I don't have this project in like a clean version, so I'll have to clean it up before I share it with you. But please tune in on Discord. If I'm going to share the project, it's going to be on the Discord channel. Can you convert a Bolt component to an editable C# script and vice versa? So this is not the case with Bolt 1, but as far as I understand, the Bolt 2 will have a similar feature. So you'll be able to compile your graph into the C# code. So I'm going to share the Discord channel link after the webinar. It's going to be one of the last slides in the webinar. Can I access Bolt variables from C# script? That's a great question. I think there was an interface. I don't remember now, but the usual workflow is that you create a Unity event and you use Unity event to interface between Flowgraph and C# script. Does the Bolt support VR SDK? So Bolt is able to call most of your C# methods, so it should be fine working with the VR SDK. Let me move on to the second example I wanted to show you. So this is the interactions coming from the 3D game kit. So this is my character, right? And let's say we have a door in our world, and now to open this door, I need to basically walk on the button, walk on top of that, and somehow my script, my game is going to know that I'm here on this area, and it's going to open the door, right? So how can we implement this behavior? So let me start from here. So on my, let me find the button here. All right. So here, what I want to utilize is this on trigger enter event. So I'm going to add a sphere collider component to my object. Usually the colliders, they are represented by this green outline. Let me switch quickly to my presentation. I'm going to briefly explain you how this works. So every time my player stands on a button, it's going to overlap with this green collider, okay? And if the collider is set to trigger, we are going to receive some callbacks. There's on trigger enter. So on the first frame, when your player starts to interact and overlap with the collider, you're going to receive the on trigger enter. On every subsequent frames that you remain within the bounds of the trigger collider, you're going to receive on trigger stay. And on the first frame, when you've left the trigger, you're going to receive on trigger exit. So in our scenario, we are going to use the on trigger enter. Okay. So the important information here to note is that you need to set your collider to trigger, because otherwise, if it's not a trigger, our player is going to collide with the collider instead of sending this callback. So that's why I set this is trigger here. And on my button, I'm going to add a new component. This is going to be again a flow machine. This time I'm going to use the embedded one. All right. So instead of creating a new macro here in my assets, I'm going to use the one here in my component. And I'm going to right click and go and find the on trigger enter. Okay, on trigger enter. And from here, I'm going to check the collider that's colliding, that's basically intersecting with this trigger area. And what I'm looking for, I'm going to check if the tag of the game object, so every game object can have a tag. We're going to check if the tag is set to player. Okay, so I'm going to drag this collider here. Check the compare tag. Compare to player. And if this one returns true, so if the tag is player, I'm going to set a variable on my object, and this variable is going to be named is pressed. So this will mean that our button is pressed. So here I'm going to set object variable is pressed. I'm going to set it to true. So I'm going to add a new unit here, boolean. So boolean variables, they can only have true or false. So this is the checkbox here. So right now the value is false. If I check it, if I select it, the value is true. So every time I enter the trigger and this one returns true, I'm going to set the variable is pressed to true. Now, how do I check if this one is true? I need to do a branch. So branch is like an if statement. So here in this if statement, oops, sorry, just 1 second. Branch is like an if statement. That's going to let you check sorry, just 1 second. It's going to let you check if anything that you provide here is true, then this part is going to be executed, this part of the graph. So I need to drag this true here into my set variable. And in my compare tag, just 1 sec. So here I'm comparing two strings. So this is my mistake. I was comparing two strings, so this is not going to work. What I actually want to compare is to compare a collider, the game object tag. So I'm going to look for the compare tag again, and I'm going to select the game object compare tag. All right, and this one is going to return Boolean. So you can see that they have the same color. So I made a mistake here. I don't want to compare strings. I want to compare the tag. So here I'm going to connect them together. Right, so if I enter the trigger and the tag is player, the isPressed should be set to true. Now I want to do the same thing for onTriggerExit, but now instead of setting this to true, I want to set it to false, and of course here I need to use the onTriggerExit. Right, so let me quickly check if this one works. What I should see is that when I stand on a button, it should set the boolean value to oops, it doesn't have the variable here, it didn't save it. Let me add it here. isPressed boolean. All right. Okay, so you can, I hope you can see it here in the flow graph. So every time I leave the trigger area, you can see that there is this kind of nice visualization of the flow. So it shows me nicely where the flow comes from. It comes from on the trigger exit and on trigger enter. So when I enter, you can see that it lit up for a moment, and my variable should be set to true. When I leave the trigger, it's going to be set to false. All right, and now what I need to do next? Somehow I need to tell this button where are my doors and how do I want to open them. So in my variables, I'm going to add a new variable called door wing. Okay, and this is going to be a transform. Transform is responsible for setting positions, rotations, and I'm going to select my door wing here and assign it to my variable. So I'm going to drag and drop this door wing here into this parameter, and now from my script, from my flow graph, I should be able to reference it and modify the rotation. So what I want to do is to grab this door wing and adjust the Y rotation. Okay, so here I'm going to do something very simple. I'm just going to grab the update. So on every frame, I'm going to check if, so branch if get object variable. So if my boolean is pressed, if my button is pressed, if it's true, I will create vector 3. Create a vector 3. That's going to be 0, maybe 120. So this is going to be angle on a Y when my doors are open. And 0, 0. Okay, so this will happen when it's true. When it's false, the doors are going to be closed. So 0, 0, 0. So let's connect it like that. And now in 3D graphics and video games, we have this concept of quaternions. So we usually don't represent rotations like we do here in angles. We represent them as quaternions. So before I assign the position to my door wing, I need to create a quaternion. So I'm going to look for quaternion Euler. Quaternion Euler, and I'm going to pass the vector that I created just now. I'm going to copy and paste it, do exactly the same for the false. So when it's not pressed, it's going to create another quaternion with rotation 0, 0, 0. And after this is done, I need to get my door transform. So I'm going to look for get object variable door wing. I need to get and set the rotation. So here, set rotation, transform set rotation. All right, so I'm going to create a copy of that here. And I'm going to connect these two together. So now on every frame is going to set the rotation to 0, 0, 0 or 0, 100, 20, 0. So now right now it's happening really, really fast. I did it in the update method because here I could do like a very slow animation of opening door. So what I could do, I could basically grab the rotation here. Rotation, get rotation, and instead of setting the rotation directly, I could do something like in linear interpolation. So I could do lerp, quaternion lerp, AB. Here I would pass something like time, delta time. And pass it here instead. So now let's actually multiply it before we pass it. Let's multiply it with float literal, something like 10. Let's multiply them together. So now when I open my door, they should kind of more gradually open instead of opening right away. Oops. Oh, sorry, actually on close, because I connected this one to the false branch. So now the closing is very gentle. And you could do exactly the same thing for the upper part of the branch. Okay, so before I continue to the next one is going to be the AI state machine. I'm going to quickly take a look at the chat and see what kind of questions they have. Can we add multiple update in the Flowgraph? That's a great question. I think you should be able to do that. Yes, so you could make them kind of parallel. So instead of having everything going from the same update event, you could basically copy and paste it and use it in multiple places. Are there any elaborate video tutorials or help guides that will be made available to Unity users? So if you go to Unity website, there is a Learn tab and has many different tutorials on virtually any Unity topic. So please go ahead to the Unity website if you look for more tutorials and look there. Which version of Unity Bolt supports? So the Bolt, it supports Unity 2017, 18, 19, and 2020. And probably it's going to support versions of Unity to come. So 20.1. It's quite far in the future, but they probably should be supported as well. Can you create your own custom events? Yes, you can, and this is something I'm going to show you in the next example. Does Bolt work well in the project with all the legacy C# components? So yes, you can kind of mix them together. So you could call some C# functions from your Bolt. You could create some custom nodes. So maybe part of your team doesn't want to write a code. You could create some custom nodes for them and expose them here in the Flowgraph. So they worked quite well together. The live edit, yes, it's available. I think it should be available on the embedded flow machine, but that's actually a great question. So this is something I would have to try. The live edit, it should work on the embedded flow machine, but I'm not sure if it's going to be saved. Because the reason why it's saved right away when you edit it here on the macro is that the macro is an asset in your assets, right? So when you modify your assets, they are always saved. But when you modify parameters in an inspector, you usually lose the parameters that you set when you leave the play mode. There is slight overhead when using Flowgraph compared to the C# scripts, and this is something I'm going to mention at the end of the presentation. So if you are very proficient with coding, you should probably use the performance critical code using C# instead of Flowgraph, because C# code is going to be always faster than Flowgraph. Okay, there are some more questions about the overhead. I'm going to address them at the end of the presentation. For now, let me move to the next step. So in the next example, what I want to create is this very simple patrol behavior for my enemy. All right, so he's going to move from point to point, and then when he sees the player, he's going to go into the chase mode and start to chase us. So, so this is our enemy, and he's going to find the closest patrol point. He's going to move there, wait for 1 second, go to the next patrol point, and do this indefinitely. Then I'm going to add my custom-made perception component to the enemy, so that he has the ability to see the player. So first he's going to measure the distance between the world position of the player and his own world position. Then he's going to check the angle, if the player is within the vision angle, and if that's true, I'm going to broadcast a custom event that's going to tell me, hey, player is now visible. So this will allow me to transit to chase state. So in a chase state, we're going to follow the player, and once we're in a hit range, we're going to attack. All right, so this is something we want to create in our state machine graph. So back in Unity, I'm going to open my third scene. So this is how it looks like when it's finished. Here's the enemy. He spotted me. He began to chase the chase state, and then he attacked me. So let's take a look at the graph. We are running out of time, so I'm not sure if I'm going to recreate the entire thing. But just to show you how to create the state machine graphs, it's very similar. You just have to right-click, go to Create, Bold, and instead of Flow macro, you want to select the State macro. And it's going to create this asset here. You can see that the icon is slightly different. We have this 9 dots instead of cubes. So this indicates that we are operating on the state graph. So the state graph, it's a little bit like the animator state machine. We will be able to transit between different states. So my basic state for the enemy is going to be this alive state. Let me attach this alive state macro here. I already have some animation events states here. So basically here I'm listening to animation events from the animator. But coming back here, what I want to do, I want to create this patrol state, chase and attack. So I'm going to right click, go and create a super state. You can see that we have flow state and super state. So flow state is the one that's going to allow you to execute some behavior, and super state is something that allows you to embed another state inside parent state. So I'm going to start with the super state. I'm going to name it, sorry, let me move back here. All right, so here the title is going to be patrol. And if you want your state to start right away when you start your flow graph, when you start your behavior, you want to right click and press toggle start. This will enable it. It's going to start execution right away. So in my patrol, you can see that I have this flow state, right? So this flow state will basically allow me to create some behaviors. And instead of using the embedded, so here the default one is embed, I'm going to switch to macro and use the one that I already created beforehand. So I have the select target, and this is just another macro that's selecting different patrol points. So here in my alive state for the enemy, the one and only state that's going to be executed is the patrol state, and here I'm basically reusing the graph that I created before, that will make him move along the patrol points. On the variables, I created this patrol points parameter variable. That's a list of game objects, and here I can nicely reference different game objects. In my example here, there are patrol points. So if I press play, he should successfully choose the right patrol point and move between them. Right now, of course, he will not attack me. He will not chase me because he doesn't have any knowledge of the player and how to transfer between states. All right, so now I'm going to create a new flow state, and this flow state is going to be chase, and the second flow state is going to be attack. And how do I transfer between these two, between those three actually? Just as with the animator, I can create transitions. So if you right click on your state, you can select make transition and drag this line here, this arrow to the chase. So we created transition from patrol to chase. Now we can do the opposite as well. So make transition from chase to patrol and from chase to attack. Make transition, so we can transition back and forth between those states. On my enemy, I've also added a flow machine that's called perception, and this perception is just looking for the player position, and it's getting the distance and then calculating the angle. So if the distance is less than what I set to be the vision distance, it's perception. Here I created the graph variable, so instead of object variables, I don't save these variables on the object, I save them directly in the graph. I have this vision angle and a vision distance, so if the player is within vision distance, and if my angle, so basically for the angle, I calculate the delta position. Okay, so this is my player position minus my position, subtract. I normalize it and I create a dot product. So this is a way for me to check the angle. If my angle is lower than the vision angle, then I can see the player. And now I check if I saw the player before. So I get the variable. If I can see player already, then I do nothing. But if I didn't see player before, then I set can see player to true, and I trigger the custom event. So the custom event you created by typing the trigger custom event. Here you provide the name of your event, and you can also provide some arguments. So here in my example, I have one argument. This is a boolean, true or false, and the name of this custom event is spotted player. One thing I forgot to mention is how do I know where the player position is? So this is something I added to my scene variables. If you take a look here, I have a scene variables game object, and I added a player variable that is a transform, and I assign it to my player. So if you create your scene variables, they can be accessed from any state machine, any flow graph. So this is a very convenient way to create something similar to a singleton pattern. All right, so I have perception, I have my patrol points. Let me come back to the enemy. So we are really running out of time, so I'm just going to show you the completed version. In the chase state, what I did on state enter, so when I enter the chase state, I set my navmesh agent. So navmesh agent is the thing that's moving my enemy. I'm going to set the set stop to false, so he is able to move. And then on every update, I'm going to set its destination to my player position. But now, how do I know where I can see the player? I select the transition from patrol to chase, I double click on it, and you can see that here I listen to the event. So I added this custom event like that. Oops. I added my custom event like that. I provided my name spotted player. I set the arguments to 1, so I can read the Boolean value. All right, so every time I spot the player or he goes out of sight, I get a true or false variable. If it's false, then we do nothing. Basically, we lost the player from our sight. But if it's true, we start to see the player. Then we stop for a moment. I added this this animation for him. So there's this spotted trigger that I set on the animator, so he can play this funny animation. I wait until the animation is finished, and I set this Boolean in pursuit on the animator so he can start to play running animation. But the most important one is that in this execution flow, I execute this trigger transition. So the trigger transition is the thing that's going to make move from the patrol into the chase state. One thing I also didn't mention, but it's important, is that I added this wait node here. And to have this wait node, so basically the execution here is waiting until this delay time is elapsed. To enable that, you need to select your event and you need to toggle the coroutine toggle here. So this one has to be on. And if it's on, then you can use the delay, wait for seconds nodes to basically delay the further execution of your script. Now, how do we know that we want to go from the chase to the patrol state? So here I'm using update method. On update, I'm checking if I can see the player, and if I can't see the player anymore, then I basically transition to my patrol state. And how do I transition from the chase to attack? This is done by checking if the distance between me and enemy and the player is less or equal the attack distance. If yes, then we transition to that new state. All right. So let me play it one more time. All right, and now all the transitions should work kind of as intended. So this is very simple AI state machine behavior, but as you can see, this could easily become kind of more complex and more like real life scenario AI state machine. Inside the patrol, you could create sub-states, like create a super state, and here you could maybe create patrol alert and patrol normal, so you'd execute different logic when your AI agent was alerted and not. So this is actually quite a powerful feature. One thing I didn't mention during the presentation, but I want you to be aware of it, is, let me roll back here to my door button. You can actually organize all of these different nodes in a nicer way. So if I would drag my mouse button here, click and drag with the control button, I'm able to create a group. All right, so the group can have a name, something like trigger events. So now instead of arranging them one by one, I could get the entire group and move it around as a group. So this is a useful feature of the Flowgraph to organize your visual scripting more in a more human-friendly way. Okay, so before I go on to the Q&A chat, let me give you kind of quick overview of what's different between writing a code in C# and creating a visual script. So visual scripting is for all experience levels, right? If you haven't done programming before, and this is a great solution for you because it can get you up to speed, and without any coding knowledge, you are able to create the gameplay behaviors. Whereas coding in C# it requires some programming knowledge. Although C# it's not the most difficult language, it's still, the learning curve is much higher than visual scripting tool. The visual scripting, it supports the live update. So if you create some sort of a prototype and you want to very quickly iterate and see if your gameplay works or not, Bolt is a great for that, because you don't need to wait to recompile. Like with C#, every time you modify a script, you need to wait for it until it recompiles. You need to restart your game, so it kind of takes time. And with visual scripting, if you do prototyping, the iteration time can be improved quite significantly. One question that appeared in the chat quite frequently was the performance overhead. So with any sort of visual scripting solution, you are going to see a CPU performance overhead. So for the performance critical code, like maybe iterating over a loop where you have hundreds or thousands of objects, it's always better to use it in a C# script instead of the visual script. All right. So let's say if you have a player controller that's checking collision with many game objects in a scene, or maybe it's iterating over a large loop, it's always better to have it in your C# script instead of the visual graph. Here are some useful links that I wanted to share with you. Recently we had a Unite Now session, introduction to Bolt. So if you want to have kind of another video about how to create interactions using Bolt, this is a great place to start. This is the link to the asset store to download Bolt. It's not really needed here. You can easily find it on the asset store if you just type in Bolt. There is a great platformer tutorial on our Unity Learn website. So there was a question in a chat asking, how can I learn gameplay programming? How can I learn how to use Unity? How can I learn how to create games? Unity Learn is probably the best resource you can find on the internet. So go into this link, click on this link, and it will bring you to the platformer tutorial using the Bolt visual scripting. And finally, if you want to see the documentation manual, this is the link right here. Okay, let me open the Q&A tab. Okay, so does Bolt run as fast as a C# code? So no, the Bolt is always going to be slightly slower than C# code, and the larger the script, the more difference it will make. So if you iterate over thousands of objects, this is going to be much slower than C#. But if you do some simple things like maybe on trigger enter, on trigger exit, the difference is going to be neglectable. Hello, does the input axis block works as in using WASD buttons or arrow keys? So it works with both. If you go to Unity and go to edit project settings input, inside the input manager you have the horizontal and vertical axis, and you can see that we have the positive and negative buttons for both of these axes, and we reference left right arrow keys as well as alternative keys. So this is going to be our AD and SW. So this is something you set in your input manager, and you can find it here in edit project settings input manager. Can I create functions like AI search, walkthrough attack in C# code, and let the designer use Flowgraph to design AI behavior? Yeah, so I think this is something you could do, and it's I think this is a right way of thinking about it. So very often we want to create something very performant and very dependent maybe on some C# code, right? So you could create this C# code block and then expose it. You could run it inside your Flowgraph. Okay, so the another question was how can you access the C# script from Bolt? So it's a great question, and I think the easiest way is, for example, here I selected my enemy. So there's the Chomper here, right? And he has a damageable script attached to it. So the easiest way would be to just right-click, bring this fuzzy search, go to Chomper. So this is your game object. And then you can basically go through the list of components. So I would select my component, my script component, and then it basically uses a reflection to get every single method that can be executed on the script. So I can set invulnerable, max hit points, and interface with all the C# methods. So I think I answered this one already. So there is a 2D and 3D game project tutorial, and if you go to Asset Store, there are actually some nice platformer and third-person play projects. Oh, my internet is a little bit slow now. But basically, if you type in Bolt, Unity Bolt is going to give you in the suggested you should see the Bolt Kit platformer tutorial, third person. So I think these are great projects if you start learning. These are great ones if you want to start with like third person, first person, and see how different behaviors can be done using Bolt. Yeah, so clicking convert will convert the embedded Flowgraph to a macro. Sorry, I didn't quite catch the question. cannot view bolt as a C# at this stage, but it's so currently we are at the bolt. We are using the bolt 1, but there is also a bolt 2. So bolt 2 has a feature that allows you to, as far as I know, last time I checked it, you have a feature that allows you to generate a C# code based on your graph. So currently bolt 2, it's feature complete and it's in an alpha stage, so it's actually still quite early in the development. So what we suggest now is for 2019, 2020 versions of Unity, probably for production you should use bolt, because bolt 2 is still quite early in the development. It's in the alpha stage, so we don't recommend that you use it in the production. But if you are delivering learning programs, I think bolt 2 could be something interesting. So if you have time, please take a look at the bolt 2. Bolt automatically creates a folder named Ludic. So Ludic is the name of the developer that created this asset, and after we install, Bolt is going to import some DLLs here, some assemblies, and generate the structure for you. Can you group logic into black box functions? So this is a great question, and yes, you can do this. This is something I've done behind the scene here in the. Let me just open it again. I've done it behind the scenes here. So my enemy inside the patrol, there's this select target, right? And the select target, it's my flow graph, and here in the end, after I do check if he arrived at the current patrol point, to get the new patrol point, I actually encapsulated the entire thing as a kind of separate function. And you can do this by creating this thing called a super unit. And a super unit can be basically just like any flow macro. So you could have an input node, all right, and you could also add some output values. So if I do like value outputs, I could maybe name it something like out float type float, right? And then after I do all the calculations, I could get the output node, right, and provide some sort of output variable here. So yes, the super units are a way to go if you want to create this kind of encapsulated functions. Can you comment the code? So I think a way to comment that would be to create these groups. Okay, so for example here I have this get item, get position. So I would click on my keyboard control, click here to select these two nodes, and I would name the group something like get the position of current item, and I would use this grouping functionality as a comment. Yes, both works with 2D, both 2D and 3D. I think I answered this question before, so can we add more animation to the button? Yes, this is totally possible. Just for the demonstration purposes, I use this coded animation using the linear interpolation to move between open and close position rotation. And yes, you should be able to create the entire game using Bolt. If it's maybe simple Pokemon style RPG, this will be totally fine. If it's something more complicated, maybe you want to simulate tens of thousands of moving objects, this will be more challenging because of the performance overhead. But for not very CPU performance heavy games, Bolt should be totally fine. Yes, Bolt should work with scriptable objects. So there was a question about debugging. For debugging, something that I use quite often when using Bolt is the debug break. So here I have my button, right? So on trigger enter, let's say I want to check if this part of code is being executed. So the first thing I would do usually is just to see visually if there is this kind of flow animation being played here. Okay, but sometimes it's too fast and it's really hard to grab the exact moment. So what you could do, you could come in here and type in debug, and from the debug you could use the debug log, right, to send a message to a console. So this could be something like string literal here. You could type in a message like hello entered trigger. Okay, so if I do this again, you can see that in my console I have this message. What you could also do, you could use the debug break. So this will basically pause the entire game when this node is being executed. So when I come here, you can see that it paused the execution, and here I know that, okay, I'm here in this moment in my Flowgraph, and it displays, and I can investigate what's happening in my scene. After I figure out everything works fine, I can resume the game. Yeah, the visual scripting solutions are usually slower because they are, especially Bolt, because it's interpreted. Like we don't really compile this thing that you can see here. It's all kind of interpreted in the runtime, so that's why it's a little bit slower. It has some advantages though, like you have the live update functionality. Another thing is that it uses reflection. So reflection is a function of C# that allows you to get names of the methods, names of the classes. So this is a little bit slow. So these two things make visual scripting with Bolt slightly slower than writing a C# code. I get a warning message. Your Unity preferences are set to reload scripts during play mode. This causes instability in Bolt plugins. How to fix it? I would probably try to install Bolt in an empty project, see if it happens as well. If you still have this issue, maybe forums would be a great place to ask for questions like that. Yeah, so I'll need to clean this project a little bit, clean it up a little bit, and I'm going to share it on a Discord. So just to, so this is the Discord link. Thank you, Kian. Yeah, I'm going to post this video on YouTube. I don't plan any more advanced Bolt webinars at the moment, but if I can see in the survey, so if you have time, please fill in the survey. So this is the link to the survey. If I can see in a survey that many people ask me to create a new webinar more advanced about Bolt, then this is something we'll consider.